Hey, what's up, everyone? Good morning, good afternoon, good evening, whatever time of day you're deciding to watch these videos. What I want to cover in this last video or two, depending on how much I babble, I try to keep these short and not super long so I can keep your attention, is to kind of go through our very first lesson. And that is something that's super, super important for us to cover before we really get slamming into a majority of this material. So if you've already done lecture two's homework and videos, that's totally fine. This will kind of weave into that. So before we get started here, what I want for us to do, or what I would like for you to do, is to think to yourself, what is the difference between weather and climate? What is the difference between weather and climate? So I encourage you to pause the video, think to yourself, think, and let's see if your hypotheses are correct. And so let's break these things down, shall we? So when we think of somewhere's climate, we could maybe say, okay, well, San Francisco has a pretty mild climate overall, right? It's not too hot, it's not too cold, it doesn't really rain all that much unless it's winter time. If you're living kind of over by the ocean, like if you live here on campus, or if you live in the outer Sunset or Richmond, you never actually see the sun. I'm just kidding, sometimes you do. But, it's like super foggy, or can be really foggy there right by the coastline. So, or maybe think about maybe where you're from. Maybe you're not from San Francisco, and think about the climate that you experience in that area. And then I want you to think about what's the weather of where you are right now. Right here, right now, look outside if you're not outside. What is the weather, and how would you explain that? How would you explain the weather of what you're experiencing right now? Got it? Okay. So let's go back to this idea of San Francisco and kind of work through what I'm trying to throw down here. So what we're looking at here is average daily high and low temperatures for San Francisco. Going from January to December is on our x-axis, and on our y-axis is temperature. So our red line here is indicating the daily high temperature averages for the city, and the blue line is the daily low temperatures for San Francisco. So I encourage you to maybe pause this video for a second and see what you observe. We're going to be looking at lots and lots and lots of graphs throughout our time together. And this is our first one, right? So pause the video and make note of what you see here. Do you see that our warmest time is actually more in September and October, rather than say June and July, when most places have their warmest time here in the Northern Hemisphere? Do you see that? Kind of fun. Do you see that there's not a big difference between the high temperatures and the low temperatures, meaning that our daytime highs and our nighttime lows, there's not a lot of fluctuation? Kind of cool. And then our overall annual average range is also not that much, right? The coldest on average during the day that it gets is 56 degrees, and the hottest is 72 degrees. That's not a big extreme in differences. And maybe you've lived somewhere where it has been super extreme, or maybe you've even visited somewhere where during the day it's ultra super crazy hot, and then at night it cools down quite a bit. Like in the desert areas, that happens quite a lot, like in Phoenix or Tucson or Albuquerque, things like that. So this is what we would call San Francisco's climate of temperature, just of temperature, right? We could talk about San Francisco's climate of moisture content and cloudiness and raininess and all that kind of stuff, but this is just looking at temperature. We're going to keep it simple with the temperature stuff right now. So this is SF's climate, and then this is San Francisco's forecast for the weather, right? So we're going to look often at the National Weather Service, which is basically the only source that you should be using for your forecasts. I know you're like, what? We'll get there eventually, don't worry. But these are the forecasted values for San Francisco downtown. This is for SoMa area. So it's where I live. So I always just have that zip code in there. So just notice the temperatures here. And what we can do is compare what we are experiencing now, and is that considered to be normal for this time of year? And if you compare these temperatures, like this afternoon's high is 69 degrees, and if you look at the average for the end of August, yeah, honestly, that is pretty average. One could maybe even argue a little bit below average, right? So a little bit cooler than normal. And then even our low temperature for this evening is supposed to be 59 degrees. And one could argue again also that we are also maybe even almost a little bit warmer than average for our daily, for our evening high or evening low, excuse me. So we'll often kind of talk about these variances, or this is something that comes up a lot, is like, is it above normal or below normal? Like, what is normal and is it above it or below it? That kind of thing. So kind of a neat little concept there. So an easy way, I think, to explain the big differences between weather and climate is that climate is what you expect and weather is what you get. We would expect it to be in the high 60s, low 70s this time of year. And we would expect it to be in like the high 50s, low 60s this time of year at nighttime. Is that what happened? Absolutely. For this year, anyway. If you're watching this for a different semester, maybe we're looking at something different, right? Kind of fascinating. Or a different time of year, right? Or maybe think about some times that you've experienced out of the ordinary or anomalous weather in your time. So that's kind of the jam with that. So what is weather? So how we will explain weather is the state of the atmosphere at a given time and place. So this refers to temperature, humidity, wind speed and direction, present weather, cloud cover, etc. Again, going back to that idea, like if you were to describe every weather aspect where you are sitting right now, what descriptors would you use, kind of thing? Whereas, and it's like right here, right now, and it changes from day to day, minute to minute, second to second. And whereas climate is an average of all those above conditions, it's not just temperature, which is what we tend to think about, right? Especially when we talk about climate change and stuff like that. But it does also go back to wind speed and direction. Maybe you've been to the beach and you've wondered why all the trees lean over a certain way, because most of the wind blows that certain way, so the trees hang that way. Kind of cool, right? So we're all connected. It's a really cool little thing. So I do just want to mention that the scientifically accepted length for a comparison is about a 30-year average. So if someplace only has 5 years worth of data, not a very good point, right? Not a very good thing to compare against. We want a nice long, at least 30-year data set, at least. Longer is always better. Sometimes. Longer is mostly better for these sorts of things, but there's that. So I also want to note here that you're going to hear in media some things like 1,000-year events or 500-year events or 100-year events, and those are just statistics. So statistically speaking, there will be these very extreme events that happen statistically every 100, 500,000, whatever years, but it doesn't mean that those can't happen again. So say, for example, Fort Lauderdale, Florida last year had a 1,000-year event where they got 24 inches of rain in one day. That doesn't happen very often. Will that happen again in the next 5 years? Maybe. Will it not happen for another 1,000 years? No, not necessarily, right? So I just wanted to kind of clarify some of that verbiage that can come up sometimes. Okay. So just to kind of go into again, what is weather? So weather, of course, impacts all forms of life on this planet. It can dictate whether or not you want to do something outside or travel somewhere. Maybe you were meant to go to an outside concert and then it was super rainy and you're like, JK, LOL, totally not going to that, or something like that. Or, maybe you've tried to fly somewhere and you've been stuck at San Francisco Airport. That happens to me more often than I like to admit. And then, of course, extreme weather events can cause billions of dollars of damage that can take lives, destroy homes, and things like that. So I know that's not something that really happens around here. We deal with earthquakes, which there's no such thing as earthquake weather. I really have to iterate that now. No such thing at all. Get it out of your brain. Weather does not impact movement of plate tectonics. Okay? So just throwing that out there now. And so that said, we don't really get that many destructive weather events, but things like tornadoes, monsoons, hurricanes, snowstorms, flooding, heat waves are included in here too. We don't often talk enough about that, I don't think. Heat kills people more often than you probably want to even know about. So weather is very impactful to everybody. It doesn't matter who you are, rich or poor, cat or dog, human or insect. It impacts every single living thing and non-living thing on this planet. And that's why it's so important. So I'm super excited to share weather with you. So just some examples here of some kind of crazy weather events maybe you've not, or maybe you have or have not experienced before. I love lightning. You'll come to learn this very quickly. Lightning is a very beautiful expression of energy in our atmosphere that we can visibly see. We don't get it here very often, but when we do, I freak out in a good way. But it's very, very gorgeous, I think. And we also have, we don't have tornadoes here very often, though they do happen in California. If you're from Davis or from the Central Valley, you know, they out here. But we don't get very violent ones, and we'll learn about why later. But very beautiful, but extraordinarily destructive. This is flooding in Bangladesh from monsoonal rainstorms. We'll learn all about monsoons later on as well. This middle picture here is of a crazy snowstorm. We also don't really get snow here in the Bay Area, so maybe you've been stuck in Tahoe, maybe if you're a snow sports person or what have you, but or you're from somewhere that has gotten crazy snow before, but you know, we don't often get feet of snow covering our vehicles, right? So it's kind of wild. And this last photo here is a before and after photo of the island of St. Thomas after Hurricane Maria, I want to say. Oh no, excuse me, Hurricane Irma in 2017. So check out how beautiful and green it used to be, and after a Category 5 hurricane goes on top of it, it can completely strip the flora and fauna of the region. So pretty wild how destructive Mother Nature can be. And I'll say this a lot, Mother Nature takes hundreds to thousands to millions of years to create, and she takes 2 seconds to destroy. It's wild. Pretty interesting. All right, last little bit that I want to mention here is that it's really fascinating and really, really cool that weather patterns actually influence each other all over the world. For example, a typhoon that hits the Philippines can actually have overall implications here on the weather patterns in the Bay Area. It can cause atmospheric rivers to be more intense, which gives us more rain. It can cause, you know, in times that we wouldn't normally have rain, things like that. Or thunderstorms in the Indian Ocean, just south of India, can actually impact temperature and precipitation in the middle of the United States over time. It's wild. It's kind of cool. It's what I ended up studying throughout my graduate school career. So we're all connected. It's all here, and it's really cool. And I'm really excited to share these things with you. So hopefully we'll get some interesting examples throughout our time together. And I'm super, super hyped to be able to share all these things with you. Thanks again for sticking with me through another video. I appreciate your time and attention, and I will see you upon my return. And thanks again so much for watching. Appreciate it.